Monopoly has been a classic board game for nearly 90 years. Some people enjoy it, but most insist that it is far too long. Personally, it is one of my favorite games, as long as I do not end up with the thimble. Because, come on, can you see a thimble becoming a successful capitalist? No matter what your opinion is on Monopoly, we can all agree that it is immensely more enjoyable if you are winning, and your victory is largely based on the investments you make. Should you buy a higher rent property that almost never seems to collect money, or should you buy a lower rent property which is landed on much more often? To answer this question, we first need to obtain some data. We can get most of this from the actual board game, but there is one bit we'll need to find ourselves: how often the properties are landed on. Conveniently, I made a simulation just for this purpose. My simulation takes 1 million turns and counts how many times it lands on each space. The numbers do fluctuate slightly, as you expect them to in real life, but for the most part they are relatively consistent. We will use these results as percentages in our calculations. Alright, it's analyzing. Almost there. Alright, so we have our results. Jail's mostly landed on property because it's the easiest to get to. You can get to jail by landing on the go to jail space. You can get there by rolling doubles 3 consecutive times, or you can just land there. So we will use these results as percentages. So we'll divide the numbers on the right by 1 million to get our percentage. But before we go on to do our math, I should establish what we are assuming and what we're ignoring for this project. We are assuming that all properties in a color group have been bought, that hotels are immediately purchased after the properties have been obtained, and that we own no properties except for the ones in the color group. We are ignoring all money obtained between the buying of the set and the building of hotels, as we cannot predict when the hotels will be built. We are ignoring chance and community chest cards, which sometimes send the player to another space. The last thing I should note before we start doing math is how we are going to measure the goodness of the property group. The comparisons will be based on how long it takes the property to make $1,000 profit. In other words, how long it takes to make $1,000 and regain the money lost buying and developing the set. Now let's start with our math. We will begin with the Browns, Mediterranean, and Baltic. Mediterranean is landed on 3.27% of the time, while Baltic's rate is about 3.36%. They both cost $60 to purchase and $250 to build a hotel on each, which means that we will spend $620 on the entire color group. Next, we need to calculate the average amount of money made by each property per turn. This can be found by multiplying the percentages previously mentioned by their rent with a hotel. 0.0327 times 250 is $8.18 per turn for Mediterranean, and 0.0336 times 450 equals $15.12 for Baltic. The sum of these two rates, $23.03, is the average amount of money made by the entire color group every turn. If we divide 620, the cost to buy the properties, by 23.3, we'll find that it takes us a little under 27 turns to regain the lost money. Dividing 1,000 by the same number gives us a quotient of 42.92, which means that it takes the Browns 69.53 turns to make $1,000. All that's left is to repeat this process for all of the other property groups without any complications whatsoever. Shoot, I forgot about the utilities. The utilities don't have a stable rent. The rent is 10 times the number shown on the dice. For instance, if I roll a 4, then I pay $40. To work around this issue, we'll estimate the rent at 10 times the average number rolled on the dice. First, I will make a chart that shows the sums of all the combinations of dice. Right away, it is obvious that 7 is the most rolled number. Moreover, if we take the average of every number on this table, we find that the average number rolled on 2 dice is exactly 7. Hence, we will assume that the utilities have a constant rent of $70, and we can calculate the number of turns to make $1,000 like normal. Time for the results. In triumphant first place, we have the oranges, which make $1,000 in a speedy 27.53 turns. This is likely due to the fact that the oranges are fairly close to jail, which is the most visited space in the entire game. They also have fairly high rents for fairly low costs. In second is yellow, with 30.81 turns, closely followed by red with 31.94 turns. Green and blue are almost tied for fourth place at about 34 turns each. After that goes pink, white, brown, the railroads, and in last place, the utilities, which make $1,000 after a laughable 261 turns. What is most remarkable in my opinion is the fact that the blues, the most expensive properties on the board, barely got honorable mentions. So, how can you use this data in your Monopoly games? It can be very helpful to know which properties are the best, especially when your opponents don't. With just a little bit of math, even a thimble can become a Monopoly champion.